years, but Jim tells me you've been with Intel for 14 years, and you started when you were 20 years? No, maybe a little older.
Yeah, a little bit older than that.
For a while. Exactly, yeah. But Jim is here today, and you're going to be doing we're talking about transforming communications networks, because that's your baby. Jim is actually the technology marketing manager. And the good news also is that Jim is going to be sticking around after his keynote. So if you'd like to come up and chat with him a little bit and talk a little bit more in depth, he'll be sticking around for about an hour.
Yeah, an hour and a bit.
Perfect.
We'll see how much interest there is.
You will? Perfect. All right, ladies and gentlemen, Mr. Jim St. Ledger. Jim?
Thanks, Sally.
Absolutely. I'm going to trade you spots here.
Good afternoon. How's lunch?
Thank you.
Good. I noticed that the chicken pesto seemed to go first, so I guess this isn't a room packed with vegetarians, perhaps. But as Sally said, my name is Jim St. Ledger. I've been with Intel 14, 15 years or so, and most of my time has been spent in the telecom, datacom, communication industries. Today I'm going to just share a few insights with you, some of the things that I'm seeing and observing, some of which you may be familiar with, some of which may be new to you, and share with you some of my personal insights and such. How many people in this room either gave or received a mobile device over the holidays? Show of hands. New smartphone, new tablet. I'm not believing, no hands going up here. You already have them. Didn't you buy your wife or kids one though? I know my kids all asked for them and only one got one, but clearly hot devices. You saw Apple's report, they shipped 75 million, was it 75 million, right? iOS-based devices in Q4, and then of course the market dinged them for it because it wasn't enough. And then on top of that you add what Samsung shipped and HTC and Motorola, maybe even toss in BlackBerry's numbers wherever they may be. Clearly there's a lot of really interesting things happening in the space of mobile devices. People have embraced them. So that's one of the dynamics going on, and I'll talk about a few more as we go through. But I did want to start off, I'm going to play just a very short video to show you some of the dynamics that are happening today, as well as some of the ones that are coming up shortly that I'll speak to later on. If it plays. Or it doesn't. It only happens when you're live, right? It's a short snapshot of some of the things that you may be seeing today and hopefully things that will be rolled out in the future. I'd be remiss if I didn't mention in any Intel presentation Moore's Law. From our perspective, that's a tectonic shift in and of itself. Year over year, we're shrinking the process, developing a new architecture, et cetera, and continuing to roll out on a very aggressive beat rate, new products, new performance, new capabilities, new technology. But today I'd like to talk about a different tectonic shift, and that's what's happening in the communication infrastructure today. And I've got 4 points I'm going to hit on here. The first is Internet of Things. Not necessarily new, but there's a lot of interesting dynamics happening there. The second is in the area of big data. The video that just rolled, you saw some elements of data and intelligence in there. And I'll speak to some more things in that area. Next up is cloud computing. I was talking to Jerry Gipper earlier how he's using the cloud to store pretty much all his information these days. I think many of us are. Whether it's a SkyDrive or Google Drive or Dropbox or something else, right? They've become very popular. Now, there's a lot more coming in the cloud space. And then the last is the services evolution. You know, those of you who are old enough to remember your first cell phone that did nothing other than make calls, maybe didn't even store memory addresses in it. Then we moved into texting and others. Well, today's smartphones have clearly lots and lots more services capability in them, and certainly there's more to come. So let me walk through these 4 elements now and share with you some dynamics that are happening in the marketplace and insights on them. First up is the Internet of Things. And you know, I think there was anybody go to the M2M panel session earlier? A couple in the back, okay. Hopefully you learned a few things there, right? So Internet of Things kind of builds on the concept of machine to machine. And those ideas aren't necessarily new, right? We've had RFID tags used out in the industry for quite a long time now. What's different and what's changing is the pervasiveness of wireless connectivity. It's really becoming everywhere. And I have a couple interesting personal examples. My son is taking a course at Arizona State University. And he's only 12, so I have to drop him off there a couple days a week. And when I take him, I have to hunt for a parking spot. And you have to be very strategic because there's the old parking meters that you can usually get away with popping a couple quarters in. And then there's the new ones that are all wirelessly connected. And the wirelessly connected ones can tell if there's a car in the spot. They can accept credit cards. They can feed all that information back to the company that manages the parking structures, and of course sends out the little parking police guys who write the tickets. At the same time, they've also tied in a pay-by-phone element of things, so they largely have given you no excuse whatsoever to not pay for your spot. The second element that we're seeing more and more is in the automotive area. Right? Cars, of course, are chock full of embedded computers and have been for years and years and years, and we're just going to have more of that. But now we're seeing totally connected cars. I'm currently driving a Nissan Leaf, an electric car, and it's got, I believe it's a 2G modem in it, where it can upload all my driving information. It can upload ECM information on the car, including any faults it gets set, and then I can remotely control it either from my smartphone app or I can control it off the web through one of Nissan's applications. So it's really moved forward the capability of this concept of the Internet of Things and devices. I'm told that Tesla's cars have similar integration, and they actually can do firmware updates as well. I think the large automotive guys are a little bit remiss to have a firmware update happen in a consumer's garage overnight and the risk of what might go wrong, so to speak. So tremendous number of things. You know, the numbers that I have in this slide, 15 billion connected devices, I've heard people say that that number is actually aiming low. And as people come out with more and more interesting creative things, if you read things like Gizmodo and Engadget and others, you'll see there's some amazingly creative things that are always connected and engaged, whether it's a lawnmower or a robot or, you know, the next generation Roombas or whatever. So really interesting dynamics here, but really it's the network that's bringing this together and making it really explode and take off. Next up is the concept of big data. And big data we have broken up into 4 areas here. Volume, velocity, variety, and value. I have to find the spot where my microphone doesn't hum so much. You know, volume is exactly what it says. It's the amount of data coming off of all of these intelligent devices. It's not your classic old bolted in standalone embedded device. It's ones that are connected and providing some level of intelligence. And of course, the more items you have, the more data you have, and the more complex those items, the more data is coming off of it. Velocity refers to the speed at which data comes off of it. You know, is it a parking meter system that's just checking that spot, you know, once every 15 minutes? Or is it some medical device that's downloading data real time and perhaps thousands of data points every minute or perhaps every second? So velocity refers to that. The variety gets to what type of data is it. And we loosely break that in, you'll see in the chart, structured versus unstructured data. Structured data is what we largely know. Any engineer has dealt with structured data probably most of his life. You know, it's doing some kind of experiment, processing data that you largely can download, comma-separated variables, dump into a spreadsheet, crunch some numbers, make a decision, move forward. And that will continue to be generated by a variety of devices. What's perhaps even more interesting though, and clearly you can see the growth of it is much higher, is unstructured data. Think of unstructured data as photos, instant messages. Some people lump email in that category too. I think Google might argue whether that's unstructured since they clearly have some good algorithms for analyzing your email and serving up ads to your Gmail account. But things like videos and photos. If you watch the Facebook announcement, I think it was last week or the week before on graph search, it's exactly designed to start looking at that data, trying to understand it better. It's tools out there that are doing facial recognition on your photos and videos to try to help you sort it as a consumer and owner of the data, and businesses that are trying to mine that data for intelligence and analytics and using it that way. And the last element here really is value. And value is fundamentally what it's all about. It's not a question of how much data, how you capture data, how you analyze the data. It's what you do with it. And this is where creative companies are starting to do amazing things with it and analyzing the data. Over Christmas break, we were in a Lego store in the mall, and my son, of course, picks out 1,000 Legos every time he goes in. But there's systems that you can hold up, and it'll show you on a screen. It effectively has, I think it's an RFID tag in the box. It'll show you on the screen what's inside the box in kind of an assembled, animated fashion. And then, of course, they can take that further by having a Lego club, and the kids join it, and then they know what devices the kids are interested in. And you could take that another step further to feed that, of course, to the parents and have a little retail closed loop. So there's lots and lots of opportunities for extracting value from the data, but you do need to have some element to capture it, analyze it, and then act upon it. There's a couple interesting examples. There's one in China. They've got an initiative called the Smart City, where they're trying to use the concept of data and sensors. They've got over 500,000 cameras set up, and they have as many sensors that are doing everything from traffic monitoring to smog and pollution monitoring. And their idea is to then take all that data, crunch it through the cloud, which we'll get to next here, and then apply implementations on the street. And whether that's redirecting traffic through changing city lights, if there's a crash and you need to clear a path for emergency vehicles, maybe turning the satellites red and letting the emergent vehicle know they can go on a green side, or what have you. And ultimately they can feed that into some other municipal deployment tools that help the citizens navigate their way through traffic and other things like that. So big data has a lot more to come, and I think you're going to be seeing a lot about this. Next one is the concept of clouds. Again, not necessarily something brand new, but really starting to explode from a standpoint of engagement, right? We've all heard of things of software as a service, storage as a service, applications as a service, etc. And now we're starting to see things such as network as a service. Intel's involved in a couple of initiatives in this space today. There's one that's being led out of China, Japan, and Korea called Cloud Radio Access Networks, or we have to have an acronym, so we call it CRAN. And if you're interested in this, do a search on China Mobile and CRAN. There's a couple really interesting white papers out there. China Mobile is effectively looking at their infrastructure of a typical wireless infrastructure design of having a base station that connects to an eNote B, that connects to an RNC, gets into packet core, etc. And they're trying to figure out how can I collapse that, use some of these concepts of the cloud, and for them one of their fundamental underpinnings happens to be access to fiber to make all this work really well in these dense environments as well. And those systems, they've been now working with us, I think it's been close to 2 years, and they're in trial in many cities out there. So these are technologies that are being deployed now, and they're very creative aspects of how to use the cloud as a disruptor. What's interesting is, as China takes a leading foot forward on this one, when these guys show up at Mobile World Congress, which will happen in a month or so in Barcelona, the European carriers and American carriers are right there closely monitoring it to try to figure out how they can implement the same type of technologies. So it's another disruptor in this whole world of network infrastructure. And the last element, I mentioned this earlier after the video, is kind of the services revolution, right? And services has two sides to it, right? From the user side, does anybody here use Waze for navigating traffic in the morning? I think it's got a lot of traction in the Bay Area, effectively trying to use application on your phone to be able to share your travel information based on what speed you're traveling through, both off of GPS and tower transition, and feed that back into a system that then translates it and feeds it out into the Waze users out there as a service that they're deploying through an app. Clearly, if you're a telecom carrier service provider, you're trying to invent these kind of services that you yourself can deploy. And the reason for that is you need help on the monetization side. All right, you guys have all probably heard the story of, the explosion of mobile devices, great news for consumers and guys selling those, but the consumption of data through those and the over-the-top carriers with these, whether it's a flat rate plan or now these shared data plans, et cetera, has really put a revenue squeeze on the service providers themselves. So they're looking for ways to create these services and roll them out to subscribers and hopefully get you to pay an extra $5 a month, $10 a month, et cetera. The problem for them is, in addition to being creative to come up with those, they have to find a way to quickly deploy those. Because if they don't, several other things will happen, right? AT&T and Verizon fight it out against each other. Telefonica and BT fight it out against each other. China Mobile, China Unicom. Right? There's always a competitor there who's trying to beat you to it and then use that service to differentiate it and draw your customers over to him. At the same time, there's the app guys and over-the-top folks who could quickly come out with a similar type of offering, and if they can deploy it quicker than you can, then they're going to take all that business from you, and you're stuck having to take the traffic through your network without getting any revenue for it. So the two sides of services are a very interesting dynamic that I don't think that'll go away for a long time, and the creativity, especially here in the Bay Area, of driving those new ideas just keeps going higher and higher. Okay. So I talked a little bit about, what I call the tectonic activities happening out there. I want to switch gears a little bit now and talk about what the title of my presentation is, which is really transformation. And I want to start the discussion with what we call network transition. Network transition in our terminology and belief refers to what's been happening over the past 10, 15 years. Those of you who work in the comm space, if you knew what Nortel was, 15, 20 years ago, these guys were designing all their own stuff. And I'm not just talking their wireless equipment. They had teams doing ASICs and FPGAs and their own comms processors in-house. And you know where Nortel is today. The network transition really refers to a lot of companies moving away from these in-house do-it-yourself designs for hardware and software into either industry standard solutions or at least commercially available or COTS solutions. So it's things like ATCA, it's things like VPX, it's things like Linux operating systems. Now there still for sure are implementations and places for FPGAs and ASICs, but there sure are a lot less of them in the network infrastructure than there used to be 10, 20 years ago. The other interesting dynamic that's along with the network transition has really been the emergence and explosion of multi-core processors. And of course, Intel's in this bucket, as are ARMS guys, MIPS guys. Everybody today is multi-core. And for those of you who are maybe too young to remember why, it was the whole, we had the clock race to 3 and 4 gigahertz, and then the power that came up with that with transistor leakage. So then everybody said, this is a bad idea, let's jump to multiple cores, tune the clocks down, and find ways to go and implement multi-threaded models, pipeline models, shared implementations, et cetera. So that really is what we talk about when we say network transition. Network transformation builds on that concept and that momentum, but takes it a step further. And I'm going to talk about a couple dynamics that are happening in that space today in the domain of network transformation. The thing that's driving this from the marketplace are a lot of the things I mentioned earlier, both opportunities like the cloud element and the big data element, as well as the challenges of the Internet of Things and the pervasiveness of these devices and the need and opportunity around services. There are business challenges. I talked about the average revenue per user, or ARPU. There are technical challenges of how do you have a network that lets your $100 a month, all the data he can eat guy who's perpetually watching YouTube videos and ESPN games on his phone, and you're constantly having to feed this guy streams for that fixed data. And then maintain other customers' quality of service experience as well. It's managing your capital expenditures and your operational expenditures and keeping all of this tuned. So they looked at the traditional communication infrastructure network, as brought to you by Ericsson, Cisco, et cetera. And they also looked at some of the data center dynamics as cloud started coming into the play, and they saw an opportunity there. The opportunity really is to tap into what they're calling open innovation. And it's trying to move to a model where you can tap into what data centers are all about, which is a lot of consistent high-volume servers implemented that can be scaled from relatively high performance to extremely high performance. Single-socket implementations to quad-socket implementations. Dual-core machines to tens of cores machines. So there's a huge dynamic going on in the data center, and if you've looked at these kind of guys, what Google's doing, what Amazon's doing, what Facebook is doing, et cetera, and now that's rolling out into smaller private data centers as well, there's a really interesting dynamic there. The two specific activities that are tapping into that are software-defined networking. Everybody here familiar with SDN to some degree? A little bit. There was an SDN conference here. There'll be another one in April. There was one here, I think, in the fall as well. Open Networking Summit. The Open Networking Foundation, I'll talk more about this in a minute, they're trying to separate some of the network function between control of the traffic and devices and flows from the actual traffic patterns themselves. It's a really interesting approach. It's got an awful lot of attention in the industry, both from technology developments and market interest, as well as investment and acquisition. And then the other one that's much newer is called Network Functions Virtualization. This is an industry subgroup formed under RTECC, the European Comms Standard Body, and this got kicked off in Germany at Darmstadt actually at SDN World Conference. They announced this group, I think it was November. And they've since had their second meeting last week in France, so it's developing very quickly. I'll talk more about that in a minute, but that's really tapping into the same dynamic of these large common infrastructures and using virtualization technology as a key enabler there. How can they define a common set of standards and activities that'll go in and allow them to disrupt the historical network model and bring out rapid services deployment, managing capital expenditures and operational elements. So let me spend a few minutes now talking a little bit about SDN and NFV, the Network Functions Virtualization. I'm just going to give you a high-level look at SDN if you're not familiar with it. It's really composed of 3 layers. At the top is the orchestration layer, and this is what's doing the automation and management of things within the system. One of the key functions of this is, frankly, what I'll call making it easy. I talked earlier about how the services deployment is very, very difficult for the traditional network guys. Most of their equipment's not capable of just layering these things on. They typically have to go off to their equipment providers, buy some services adding cards, and then deploy them. And most of it, frankly, involves a truck rollout to the field to implement these cards, either in the central offices or some of the other localized data centers they have. And those are very, very expensive ways to try to roll these kind of things out. The second element is the controller. The controller is what's effectively splitting off the management of the devices in the network from the traffic itself. If there's any old telco guys in here, for me there's a big analogy to what SS7 did. Signaling System 7, right, where you had one layer that managed the setup, teardown of the call itself, and then you had the circuit switch layers that were handling the traffic on their own, two independent. So for me, the concept is very similar to what they're trying to do here in SDN. And the last one are the nodes themselves, either the midpoints or endpoints that are either asking for the data to be sent to them or generating the data themselves. This is kind of a high-level view of SDN. I mentioned earlier how this is really getting a lot of attention. There's a lot of this work originated out of Stanford, and the first conference they had, I think, it was maybe a year and a half ago or so now. They expected a small crowd of maybe 40, 50 people, and I think 300 showed up. And then they moved it to a larger venue, and they sold that one out. The last one that was here in the fall, I think, sold out, weeks before the event. You couldn't pay to register or attend anymore because it was completely sold out. Those of you who watch the, tech acquisitions know that VMware bought Nicira, who's one of the leaders in this space. Big Switch has completed a big funding round as well. There's a lot of interesting dynamics out there. You can pick your favorite tech expert on here and read their quotes on here. Clearly it's something that's got a lot of attention, and I truly think a lot of potential to absolutely disrupt the traditional historical network infrastructure approach. And the last part I'll talk about is the network functions virtualization. What's interesting about this, this is a list of the service providers and carriers who originated it. You know, some of these guys compete with each other in the daytime, but they all agreed on one thing. They have this shared common problem with their network. They can't afford it. They certainly can't afford the ramp of data rate to be able to maintain the subscriber quality of service experience, so they've got a big problem on their hands. And what they decided to do is get together, and there's good white paper on this if you want to know more information. Go search on RTECC and NFV and white paper and you'll be able to see that, or send me a note and I'll point you to the link. And they put this white paper out that sort of describes what they're trying to accomplish. And it's absolutely complementary to SDN work. It's looking for the same tie-in to the high volume server capability, and also hitting the beat rate and performance improvements, which I'll harken back to Moore's Law. And then use software and especially virtualization to enable that. And they believe by doing this and issuing some guidance around hardware and software, they can drive the industry towards a much larger economy of scale. So that's the concept behind it. This is actually directly from the presentation that Uwe Michel, who works for Deutsche Telekom, gave at the first conference in Darmstadt last fall. You know, he shows on the left, this is kind of your classic telco gear, right? BRAS, content delivery networks, routers, switches, SCSN, GGSN, etc., right? Your traditional telco router gear, independent boxes, dedicated function, lack of flexibility, and lack of scalability. Now, with all due respect to your equipment provider, your answer probably is, no, it's scalable, just buy a few more and I'll ship them to you when you need them. But for someone who needs to roll services out on a moment's notice and needs to be able to power things off during off time to save money so they can drive their OpEx down, that model just doesn't work. So you'll see on the right, they're really going after coming up with the software challenges that can take care of this, and that's from mostly the virtualization layer of things, as well as the operating system. And they do realize they need to find something that works across multiple domains. So for example, in virtualization, it's got to work on Xen and KVM and the open source models, as well as working on VMware and some of the more commercial proprietary models. So that'll be some tough work to get done. Standard high volume servers, I think that's probably something they can clearly draft the data center pretty easily, add some other elements into there to add the telco hardness to it, and figure out where that line is between, you know, traditional telco NEBS 5.9s that gets deployed in a central office versus what a cloud data center can manage with some creativity, let's call it. Then standard high volume storage, and then of course, you know, large scale Ethernet switches. You know, you've seen the switch discussion move from 40 to 100, and I've seen some 400 gig discussions out there as well. You know, that stuff moves faster than it ever has before also. So those are some of the dynamics around NFV. If you're doing any work in the comms or networking marketplace and aren't familiar with it, I definitely encourage you to read up on it. This is my last slide, and just try to take a minute to kind of bring some of the things together here. In the beginning, I talked about some of the tectonic shifts, some of the fundamental changes that are happening in the marketplace that will clearly leave some people behind. I mentioned Nortel earlier from the equipment side. You know, they're now gone. Assets distributed in other companies and other companies that are coming out of that. Transition and transformations always create opportunities as well, casualties and winners. The question is how to go and find the opportunities in there. I personally believe that if you can find an aspect to solve both the technical and business problems while leveraging scale to deliver on some of the needs and the promises of things like SDN and NFV, you've got a great chance to make this transition happen, participate in it yourself, and be successful long term. There's a lot of startup activity happening here as well. This is an area that I'm personally involved in at Intel, and it excites me to come to work every day because of the interesting dynamics and things that are happening. You know, going to some of these, the NFV conferences and the SDN conferences, there's a level of energy that I haven't seen in other places in many, many years. So I encourage you, if you're in this space, to take a look at it and get involved as well. I think it's a great opportunity for the entire industry. I'll be around for the next hour or so if anybody wants to talk to me about anything else. With that, I thank you for your time and attention. Hope you have a great rest of the day. Enjoy your afternoon sessions. Thanks again.